Welcome to the fourth module of the Solidworks Associate Prep. This module is based on the assembly of multiple parts. So what we're going to do is work on the essential parts of the exam, which are inserting a coordinate system, inserting several parts to be assembled together, creating what's called coincident and concentric mates, creating distance and angle mates, and then evaluating the mates and being able to edit them if there are any problems. So I've worked to create some additional parts from the file that we've been working with. One of those parts is a peg that fits into one of these holes, and another part is a cover that goes over the entire part here and covers it and matches the outside dimensions. So in order to make an assembly to put all those pieces together, we're going to start with making a new, and instead of part we're going to make an assembly. All the parts that I'm going to be working with are currently open but minimized, and as long as all your parts are open they will appear in this document list, in which case you can drag it from here by double click to get it to enter the assembly screen. So at this point you can take a look at your Solidworks exam and where the assemblies are, then you can check where they put the origin in their sample so that you can create an origin there as well. And the way we'll do that is by double clicking the first piece that we would like to put into our assembly. Or we can drag it in. There we go. We can just click anywhere. And then let's say we have an origin that is in the center of this face. So we need to put some X and Y axes here. So I'm going to just sketch on that surface, and maybe the origin is from this point, so we'll create an X and a Y axis here. So just a horizontal and a vertical line are fine. Okay. And in our assembly tab we can insert a reference geometry, which will be the coordinate system. This is going to say where's the origin, which is here, where's the x-axis, which is here, where's our y-axis, which is here, and our z-axis is then vertical. So we can select OK, and it will put our coordinate system 1 at this location. We can then insert the other parts, which are the cover that goes over the top, as well as the peg that goes into the hole. So now we have to make some coincident and concentric mates to get these to fit all together. And the way we'll do that is by starting with any pieces that are circular. Those will be starting with concentric mates first. So concentric just means that the circles fit inside each other and that they're equidistant from all edges. So if we select mate, we can select two surfaces to be mated with each other. So in this case we can select either the two edges or the two surfaces that are concentric with each other. So we'll try the surfaces. So I want this surface and this surface. If we click them both, we notice that this concentric mate is automatically selected, in which case we can click the checkbox and it is ready to make the next mate. If you'll notice, if I click and drag a part, it's shown to be the degrees of freedom have been limited by this concentric mate such that it slides in and out of this hole. The next mate that we can make is a coincident mate, which would basically say where do we want it to stop. If we can drag it this way, at what point do we want it to stop? And we would like it to be this face aligned with this outside face. So if we choose mate again, make sure that our selections are clear, then select this face and this face as coincident. And this will mean they are lined up. Then we can click the checkbox, and now this is fixed in position. If we click it, you can see that it actually will spin in rotation, but it will not move in or out. So if we look on the inside, we can notice that we may actually want to fix the rotation of this piece. So we will keep it in the section view so we can see our part, and as we rotate it, we would like this face to be equidistant from this face. So in our mate tab, we can choose this face and this face. Perhaps this is more difficult. Well, in any case, we won't worry about that one right now. Then we can position the cover over the top. So in order to do this, the bottom face of this cover will touch the top face of this part. That's one part, and then we'll have to align it with a couple of other edges that meet up with each other in order to get it to stay fixed in that position. So the first mate that we have to make is this face aligned with this face. That will be a coincident mate. The next thing we have to limit is the degree of freedom for it to move around in this X and Y plane, which would be accomplished by matching up this edge and this edge. As you can see now, it can move in a vertical direction, so we have to line up 2 more edges, which we'll do with this edge and this edge. So now we've aligned it such that this will no longer move. However, maybe I wanted to be able to take the cover off to show you the inside. So if we go into the mates, we can see what mates we've made and at what point they are aligned. So if I want to be able to take the cover off, I would essentially get rid of this mate or suppress the mate, and then I'll be able to lift the cover. Let's see. I can also go in each component to see what mates are within the component. Okay, so I'm just going to delete it. Okay. So instead of coincident, we should make these parallel. So we can delete these. So if we make this face and this face parallel, then we can move it. We still have some wiggle here, so the next mate, so we can make R to make this face and this face parallel, or in this case concentric. And that way they will stay aligned and it will move vertically. There's also some evaluation that we could do. When we move components, we can detect collision between them and make it stop at the collision. We can also make it make a sound at the collision. So if I drag it down and stop at collision, collision detection just between this component and this component. Make it stop at the collision. Then when I drag this down and it collides with the bottom, it will stop and create the sound. The reason it was failing before is that this peg that's inserted is actually unfortunately rotated and intersecting with this piece. Okay, so in the exam, when you make an assembly, all the pieces will be fully defined and fixed in position. So we'll do that real quick by mating this surface with this surface, which will fix those in place. And then we can move on to the evaluation. Okay, we can also change this mate from coincident to have a certain distance apart, some fixed distance. So we can set it to 5 millimeters or 10 or 15, and it will change. Sometimes if the parts are misaligned when we create the mate in the first position, they will be sort of impossible to resolve. So we will have to make sure that we can align them in the correct direction. So these buttons here will enable you to correct for any misalignment when you first create the mates. You can also create angles between surfaces. But those are usually better defined. So if a part is misaligned, you can try using flip dimension as well as this mate alignment to get them to sit in the orientation that the exam shows.